In today's video, what we're going to be learning about is problem-solving questions with two sets, and we're also going to learn about introducing Venn diagrams, which have three sets. Firstly, to get us started, we're going to do a quick review of what we did the last day. So first off, we have set difference. So as said before, set difference, here's the example. A less B is the elements of the set which are in A but not in B. So if we look at the example up here, two elements that are in A that are not also in B are 4 and 8. And if we look at B less A, two elements of B that are not in A would be 1 and 3. 2 and 6 are shared by both of them, but if you go A less B or B less A, they'll be excluded. So that's set difference. That was our first new thing last week. Then we had the complement of a set. So the complement of a set, called B complement or B dash, is the set of all the elements in the universal set that are not in B. So B dashed means the universe without B. So if we look up at our diagram here, B dash means every single element that's not in B. So the ones that are going to be excluded are 1, 3, 2, and 6. So every other element is 5, 10, 7, 4, 8, and 9. If we're to say A union B complement, that'll be every single element that is not in the union of A and B. So that'll be all the elements outside of A union B, which are 5, 10, 7, and 9. That was complement. So set difference and complement of a set are what we learned in our last video. Problem solving with two sets. The key point in these problems is we need to use the cardinal number of each set. This is indicated by a number inside a pair of square brackets. So imagine I take an example here of a set which has the elements of 2, 4, and 6. Its cardinal number is not 2, 4, or 6. They are elements. Its cardinal number is the number of elements, which in this case is 1, 2, 3 elements altogether. That's its cardinal number. So any of the problems we do here, we have to worry about the cardinal number, which is the number of elements in the set. So that's the number of elements in the set, and it's the cardinal number. So generally, we need to find out how many elements are in each region of the diagram. So for example, we might need to figure out how many elements are in the intersection, or how many elements are in A less B, which means in the set A, but not in the set B. So a question we have done out here is an example. So it's question 5 from your book. A survey was completed by 50 people. They were asked which food they liked, Italian food and or Chinese food. So first off, we know that there's going to be 50 people altogether. So the cardinal number of the universe is going to be 50. So I'm going to include that. 32 people said Italian food, 24 people said Chinese food, and 4 people said neither. So we have 32 people said Italian. So I'm going to say this can be set I, and this can be set C. So how many people said Italian altogether? Well, we had 32 said Italian altogether. And how many people said Chinese? Well, we had 24 people said Chinese. And then 4 people said neither. So that means there's going to be 4 in the outside region here. So we have 4 outside there. Excuse me. So if we think logically about this, there's 32 people like Italian food, 24 people like Chinese, and 4 don't like either type of food. So if we add those three numbers together, we get 4 and 4 8, and that is 10, carry the 1, and we end up at 60. But this survey only included 50 people, but 32 like Italian, 24 like Chinese, and 4 like neither. So we have 10 too many. So that difference means that we have 10 too many included. So we think, well, maybe that means that 10 people like both Italian and Chinese food. So if 10 people like Italian and Chinese, then I have 32 minus 10, which is 22, only like Italian food. And if I have 24 people like Chinese food, I have 24 minus 10 leaves me with 14 people like Chinese food. Now let's add those numbers together and see that they make sense. We have a 22, a 14, a 10, and a 4. We add that together, we'll get a 10. Add that together, we get 50. So we represented that information on the Venn diagram. So we represent that information by showing the cardinal numbers of each set. And then how many people said that they liked both types of food? Well, we figured that out by finding out what I intersection C was, or the cardinal number of I intersection C. So the cardinal number of I intersection C was 10. Okay, that's our first example. Now for our second example. U is the universal set. J and K are two subsets of the universal set. The cardinal number of the universe is 82. So U is 82. J is 47. So I'm going to put J there and a 47. And K is 27. So I'm going to put K there and a 27 there. Okay. Find the minimum value of the cardinal number of J union K. Use your Venn diagram to illustrate your answer. Find the maximum value of J union K. These are both complements actually. So find the minimum value of J union K complement. Use your Venn diagram to illustrate your answer. Find the maximum value of J union K complement. Use the Venn diagram to illustrate your answer. So this one is going to require a bit of logic for us. So we haven't been told how many people like both. We haven't been told how many people like neither. So first off, the question is talking about the cardinal number of J union K complement. So we need to think about that first of all. So the cardinal number of J union K. So J union K will be the union of all of the set J in union with all of the set K. That's what J union K is. But what we're dealing with is J union K complement. So that means what we're going to be looking at is everything outside of it. So everything outside of the union here. So everything outside of our set. Does that make sense to us? Now, what we need to be concerned with is thinking about this logically. So we have to have 82 people altogether. Well, let's think so far we have 47 that definitely are members of the set J. 27 that are definitely members of the set K. If we add those two together, we'll have 7 and 7 is 14, and then we'll have 74. So we have 82 minus 74, and we still have 8 left over. So that means we could have 8 people outside, 47 people here, and 27 people here, and absolutely no one in the middle. So no one that's a member of both sets. So you have 47 in the set J, but not K, 27 in the set K, but not in J, and 8 outside both of them. That's one option we could have. That is for the minimum value of J union K complement. If we want to think about the maximum value it could take, well, let's think, how can we move these numbers around? Hypothetically, could we say that every single member of K could also be a member of J? So let's think that through. Let's say we had 0 that were only elements of K and 27 that were in the intersection of J and K. Well, the total number that can be in J is 47, and we'd already have 27 in the middle, so that would mean we could have 20 there. So now our new totals would be 20 plus 27 plus 0, which would lead us to 47. But our universe has to have 82 total. So we'd have 82, take away 47. So 82 take away 47. Well, we'll have to change that to a 7, borrow 1, then we have 5, and 7 take away 4, 35 left over. Now let me double check that in my head. So if I add 5 to that, it'll be up to 52, add 3, 82. Yep, perfect. So then we'd have 35 outside. So we have 20 as members of J that are not members of K, 27 that are members of both, 0 that are in K less J, and 35 that are in the cardinal number of J union K complement. So to finish our question off, we'll have to be very specific here. So we can say we have the minimum for the cardinal number of J union K complement is equal to 8. The absolute maximum cardinal number of J union K complement would be 35. That's about as tricky a question as you'll get on these. Now, for questions for you guys to complete, they are on page 343 and 344 of your EGCO book. And these are the 3 levels I've set out. Questions 1, 2, 3, and 4, absolutely everyone should be able to do. Level 2 are a little bit trickier. They're questions 6, 7, and 9. And level 3 questions would be 10, 11, and 12. They are a little bit trickier. Everyone has to fully complete at least one level. And I would suggest, regardless of which level you fully complete, do one question in each level. So if I'm choosing to do level 1, I can fully do 1, 2, 3, and 4, but then I should have a go at question 6 and have a go at question 11, for example. Try at least one question in each level, but fully complete one level. Next, we are introducing Venn diagrams with 3 sets. So we can see in the diagram here, it's much the same as one we've looked at previously, only that an additional set has been added to the bottom. So we can see that the 3 sets intersect, and there are 8 different regions. And in many ways, the set's rules work the exact same, but we have to use our logic to think how they'll apply to 3 different sets. This page is taken from page 345 in your book, and it gives some examples of how the symbols, what they can mean on the Venn diagram. So that can be worth reading through in your own time for some of the more difficult ones. However, I'm going to start by doing an example. So the first example that's given to us here is we want to use this Venn diagram to list the elements of. So part 1 has A union B. Now I just want to make this slightly bigger. So A union B works the exact same as before. A union B is all of the set A in union with all of the set B. And we list those elements. So we have A union B is equal to, so let me see, I have E is an A, then I have I, M, A, G, D, and R in the set. Now I made a silly mistake there. That should be a curly bracket. So don't make the same mistake as me. Make sure you include curly brackets for your sets. So that's element A, the set A union B. So I can get rid of that now. Next up we have the set C. So the set C includes the elements N, G, and A, because the set C is all of the circle C. So we have N, G, and A to include there. Next up, we have a slightly more complicated one. So it's B intersection C without A. So let's think first of all, well, B intersection C is this bit here that has the set B and the set C overlapping. But then we want to exclude the part that's in A. So if we exclude the part that's in A, we only have this section, which has no elements. So that will be a null set. So we can use that symbol for null set. Sorry, so that should look more like a circle with a line straight through it. Or we could use a pair of empty curly brackets, whichever you prefer to use. Our fourth one is B intersection C in union with A. So B intersection C is all of this, and that's in union with all of A. So if we want to include all its elements, so this is number 4. So it's B intersection C in union with A. So that's going to have E, I, M, A, and G. Let me insert a little more space for us here. So then we'll go for the fifth one. So the fifth one is A without C. So we need to look at the set A here and exclude C from it. So this is the parts of A that are not in C. So E, I, and M. So A less C is equal to E, I, and M. Now our sixth one is A intersection B intersection C. So if we look at our diagram, where do A, B, and C intersect? Well, the only place where all three of them intersect is A and G here. So if we look at the set A is this, the set B is this, and the set C is that. The only place they all overlap is A and G in the middle there. So A and G are our elements for that. So this is A intersection B intersection C is equal to A and G. Then last but not least, we have A less B less C. So we have VII. So it's A less B less C. So first off, A less B, so A without B will be this part here. But then if we also want to exclude C, we'll have to exclude this bit as well. So only the orange there now. So the only bit that's there is E. So the parts of A we have to exclude are the bits that are in B, and then the bits that are in C as well. So the only thing that's left is E first there. Our next example, for this we'll have to fill out this Venn diagram, which has 3 overlapping circles in it. So first off, we've been set a few conditions. So the universe is the letters of the alphabet from A to N inclusive. The set B is the letter of the words beamed. The set D is the letters of the words defined. And the set L is the letters in the word cable. So first things first, I want to list out all these elements. So B will be equal to B, E, A, M, D, because we don't include E twice. Then the set D is equal to D, E, F, I, N. E and D are already done, so we won't include them again. And L is equal to C, A, B, L, and E. Okay, so first off, we need to look and see, are there any that are in all 3 of them? So I can see that E is in beamed, is in defined, and is in cable. So that means the letter E is going to go in the intersection of all 3, in the middle here. Then do I have any others? A is not in defined. I think E is the only one we have there. So E will be the only one that goes in the intersection of all of them. Now I want to see, is there any that are in B and D? So is B in that? No. Well, D is in both of them. So if D is in both of them, but not in L. And B is not there, A is not there, M is not there. So that means the letter D is my next one. That's going to go in the intersection of B and D. So first off, I need to decide B, D, and L. So I'll say this one's B, this one can be D, and this one can be L. So we've said D is in both B and D. So the letter D can go there. Okay. Then we can have a look and see, is there anything that's in B and in L? Well, we have B is in beamed and B is in cable. So B will go in between B and L. So a B will have to go in there. Now the last one I have to check is what is in both D and in L. So what's in D and L? So I have nothing in common between those two, but I do have A is in B and is in L. I made a mistake there somewhere. Our next problem involves filling out a Venn diagram which has 3 sets on it. So U is the universe, and the universe is going to be letters from A to N inclusive, and the 3 sets are B, D, and L. So I'm just going to decide B will be the one on the top here, D can be this one, and L can be that one. So first off, to figure out what are the elements exactly of each set, so I can figure out which ones they have in common. So the set B is the letters in the word beamed. So we have B, E, A, M, E can't be included twice, and D. Then D has defined, so we have D, E, F, I, N. E and D are already included, so they won't be included again, and L is cable, so there's no letters to repeat there. C, A, B, L, and E. So be careful your curly brackets and commas in between now. So I need to fill out this Venn diagram. So if I want to fill out this Venn diagram, I better start from the inside and work my way out. So first off, is there any letter that's in all 3 sets? So if I look, I have an E here, here, and here. So E definitely goes in the middle of all 3. So that's the intersection of B, L, and D. Now, is there any other that is in all 3 of them? No. So now I might look and I might say, okay, well, what's in the intersection of B and L, but not in D? So what do B and L have in common? So if I look at B and L, I can see that B and L both have an A, and they both have a B. So B and L both have A and B in common. So A and B is going to go in between B and L. So I have an A and a B will both go in there. Now I'll look for anything in common between B and D. So B and D, what do they have in common? B and D both have a D, but they have nothing else in common. So that means the letter D is going to go between B and D. Then last up, do D and L have anything in common with each other? So if I look here, I have F, I, N, and then I have C. So no, D and L have nothing in common with each other. So I can leave that one empty. Now to fill out the rest of the Venn diagram, I have to see, okay, what does the set B have that it doesn't have in common with anything else? Well, it's the only one that has an M. So an M will go here. What does the set D have that it doesn't have in common with anything else? But it has an F, an I, and an N. So that's F, I, and N. And the set L has an L and a C. So L and C will both go in there. Now we were told the universe was the letters from A to N inclusive. So the letters of A to N inclusive. So we think, what is not in these? So if I go B, union D, union L, complement, that'll mean everything that's outside them. So if we're going through the alphabet, A to N inclusive, so A is already there, B is already there, C is already there, D, E, F, there's no G, H, there's no H, there's no I, J, K, there's an L, there's an M, there's an N. Okay, so that's all the way up there. So we have G, H, J, and K have to go on the outside. So we have G, H, J, and K all have to go on the outside. Okay, so that's the Venn diagram completely filled out. Then we have to list the elements of these. So list the elements of B complement. So everything except B, that should be fairly straightforward. So look at what's in B, exclude that, and write out all the other elements. Complement of B union D yeah, I think anything the rest of that should be fairly straightforward. So I'll not make the video any longer, and I'll just write out the answers for these on this page down below, and I'll save you watching the rest of the video. There's a couple of the answers a little bit more complicated, so I said I'd just throw them in at the end of the video. So B complement, that's fairly straightforward. Just look at the set B and then exclude it, write everything else. Next one, B union D complement. Again, look at B and D in union together, exclude them and write out everything else. Then the next one's a tiny bit more complicated. So we have B without D intersection L. So we look at the set B and we have to exclude the intersection of D and L. So the intersection of D and L has E in it. So we have to write out B without E. So that's M, D, A, and B. Sorry, I should make that more like a D. Okay, then we have D intersection L, which is again the intersection of D and L here. So that's E and nothing else in union with B. So D intersection L in union with B will, as it turns out, just be the set B. So it's M, D, E, A, and B. Then the very last one here, we have B without D, without L. So B without D is M, A, and B. And then without L as well will be just M, because that's the only element that's in B, but not in D and not in L. Then the very next bit, we have to find the cardinal numbers of these different sets. So first off, the cardinal number of B intersection D intersection L. So there's only one element in the intersection there. So there's only one element in B intersection D intersection L. Then the cardinal number of B union D in intersection with L. So B in union with D is those two full circles, but then their intersection with L is just this bit here. So that has a cardinal number of 3. And we have the cardinal number of B intersection L. So the cardinal number of B intersection L is again actually just those 3 again. So we just have, oops, that went away at 3 and 3. I should be erasing that. Okay, and that will do us for that. Now, for questions to complete, if you go to page 349, we're only going to start with question 2, question 6, and question 7. So we'll get started on them and get them finished before our next